Roots and discriminant. Objectives. In this session, we will understand the concept of discriminant. It's used to find the nature of roots of a quadratic equation and to visualize the shape of a parabola using discriminant. We've learned to graph a quadratic function and also establish the quadratic formula for finding the roots of a quadratic equation. The roots of a quadratic equation, ax square plus bx plus c equals 0, where a is not equal to 0, are given by x equals minus b plus or minus root of b square minus 4ac the whole upon 2a. The expression under the radical sign, that is b square minus 4ac, is called the discriminant of the quadratic equation. It is often represented by the uppercase letter d or Greek letter delta. That is, discriminant d or delta equals b square minus 4ac. The nature of the roots of a quadratic equation is determined by the discriminant of the equation. There are three possibilities. Case 1. Delta is greater than 0. That is, b square minus 4ac is greater than 0. We have a positive number under the radical sign which will have a real non-zero square root. Since we are going to add and subtract the square root, we will get two distinct real roots given by x equals minus b plus root of b square minus 4ac the whole upon 2a and x equals minus b minus root of b square minus 4ac the whole upon 2a. Again, if b square minus 4ac is a perfect square, say m square, then the square root would be number m, which will give us two real rational roots. If b square minus 4ac is not a perfect square, then the quadratic equation has two distinct real irrational roots. Visualizing this implies that the parabola will intersect the x-axis at two distinct points. Case 2. Delta equals 0, that is, b square minus 4ac equals 0. Since the square root of 0 is 0, the quadratic equation has only one root, or in other words, we can say that both the roots are identical. That is, x is equal to minus b plus 0 upon 2a and x is equal to minus b minus 0 upon 2a. In this case, the parabola will intersect the x-axis at only one point, minus b upon 2a, 0. Case 3. Delta is less than 0. That is, b square minus 4ac is less than 0. Here, we have a negative number under the radical sign. We also know that the square root of a negative number is not a real number. Thus, in this case, the quadratic equation does not have any real roots. This implies that the parabola does not intersect the x-axis. Let us consolidate all these cases in a table. Here is the table for a quadratic equation ax square plus bx plus c equals 0, where a is not equal to 0. When discriminant is greater than 0, we get two real and distinct roots, also called solutions. When discriminant equals 0, we get two identical real roots. When discriminant is less than 0, there are no real roots. We get two imaginary roots. Let us consider a few illustrations. To know the number and types of roots of an equation, 3x square plus 4x minus 7 equals 0, we will just calculate the discriminant. To know the types of roots, delta is equal to b square minus 4ac is equal to 4 square minus 4 into 3 into minus 7 is equal to 100, which is greater than 0 and is also a perfect square. Square root of 100 is 10. Thus, the equation has two distinct rational roots. Since a is equal to 3 is greater than 0, the graph of this quadratic function will be an upward opening parabola intersecting the x-axis at two distinct points. Let us consider another quadratic equation. 4x square plus 20x plus 25 equals 0. Now we will find the discriminant of the equation delta equals b square minus 4ac equals 20 square minus 4 into 4 into 25 is equal to 0. Thus, the quadratic equation has two equal roots, or we can say it has one real root. The graph of this function will be an upward opening parabola intersecting the x-axis at one point. Let us consider another quadratic equation. 5x square plus 7x plus 3 equals 0. Once again, we calculate the discriminant. Delta is equal to b square minus 4ac equals 7 square minus 4 into 5 into 3 is equal to 49 minus 60 equals minus 11 is less than 0. It indicates that this quadratic equation does not have any real roots. So the graph of this quadratic function does not intersect the x-axis at all. Summary. In this session, we have understood the concept of the discriminant of a quadratic equation and how to use it to find the nature of roots of a quadratic equation. We've also learned to visualize the shape of parabola using a discriminant.